Okay, ladies and gentlemen, let's start by taking a look at distance and midpoint. Now, distance and midpoint have to begin to do with what we call coordinate geometry. Now, it's not that it's separate from the other geometries, but in this case, it deals with when we can put coordinates on an XY plane. And so the first thing you would do anytime you're dealing with coordinate geometry is you want to graph it. So if I begin graphing, go 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, there it is. Anytime in this class that you put coordinates on a plane, you must label them. Now, in this case, I'm going to label them A, but you could have just as easily labeled it 6, comma 3. Okay, let's go ahead and put our other point on there, negative 2, comma 5. So let's go 1, 2, and 1, 2, 3, 4, 5. And so it's going to be up a little higher. And so that's point B. Now, with those 2 points, we can do a number of things. We've already talked about how there's only one straight line between the two in Euclidean geometry. But the question becomes, how long is that line segment? How long is this piece between those two? That's where we use the distance formula. Now, you've used the distance formula in algebra already, so this is not new news. This should not be shocking. And of course, since it's point A and point B, maybe we can change their names. Let's call it point 1 and point 2. Now, the reason we call it point 1 and point 2 is because every point has both an x part and a y part. So if this is point 1, this is the x part from point 1, and this is the y part from point 1. Whereas down here, this would be, since it's point 2, the x point from part 2 and the y point from part 2. Using that type of notation allows us to use the traditional distance formula. And so we say x2, negative 2, minus x1, 6, quantity squared, plus y2, 5, minus y1, 3, quantity squared. Don't forget your square root. That's where a lot of people go wrong. So we come up with negative 8 squared plus 2 squared. Square root, so I have 64 plus 4 square root 68. Now, ladies and gentlemen, in this class, you cannot leave it as such. You must simplify. Do not give me decimals. I cannot stress how strongly enough I do not wish you to give me decimals. You must use its prime factorization. So 2 and 34, 2 and 17. If that is the prime factorization, that means I have a pair of 2s. So what is the square root of 2 2s? 1 2 comes outside, leaving the 17 underneath. And it is 2 square roots of 17. Now, a lot of times when we take a square root, we talk about plus or minus. Thing is, in distance formula, we would not talk plus or minus because negative distance is a ridiculous concept, at least at this point. So 2 root 17. Now I could do the midpoint for the same thing. Very quickly, we come over here and we say 6 plus negative 2. Now all over 2, comma. This is a comma because since it's a midpoint, you better have 2 bits to it. It better still have an x and a y. And so in this case, we're going to say 3 plus 5 all over 2. So here we get 4 over 2, comma 8 over 2. And I come up with 2, comma 4. That is the point. Double check it. 1, 2, 1, 2, 3, 4. So the midpoint here is 2, comma 4 between the 2 points. That is distance. That is midpoint. But that's not the only way we can use this. If we have something and we have, I can't use arrows and distance because arrows and distance mean it goes on forever and ever, and we can't do distance with something that goes on infinitely. So let's go A, B, C. If this is 2x and this is 3x minus 1, and that's what the length of this is labeled. It's an unknown distance and an unknown distance, but we have those relationships. We need some other piece of information, and that information is if the distance equals, I don't know, 14. If the distance is 14, how can I use the distance concept of distance along with this information to find x? Well, the answer would, of course, be that whatever this is plus whatever this is equals the total distance. So 2x plus 3x minus 1 equals 14. Now it becomes a simple algebra problem, and you understand why we started with algebra. Additionally, if we go over here and we say from A to B, and this happens to be a midpoint, if you know that this is a midpoint, and it says 4x and it minus 1, and it says 2x plus 6, you can use the concept of midpoint to find the missing x by saying, well, if it's a midpoint, it's in the middle, which means this distance must equal this distance. And so we can set them equal to one another. And again, it becomes a basic algebra problem to solve. So that's example 1. This is example 2. That's going to be important for you as you finish up. All right. So take a look at those. Distance, midpoint, a little bit of algebra, a little bit of geometry.